Hello everyone, welcome back to our channel NEET Techniques, and this is Vamsi. Yes, it has been many days telling you this name. Uh, our faculty were busy in some of their personal work, so we could not able to record the videos. So we'll be trying to record and upload the videos very soon, and we are trying to change the mode of action. Actually, sorry, we are trying to change the mode of action. See, we are trying to like upload videos of papers like we have some grand test papers which include whole syllabus. We will be taking up one paper in one video. I'll be doing biology. The same faculty will follow as usual: biology, physics, chemistry. We'll be taking one paper in one video, and we'll be explaining the paper with solutions and how to solve the paper within less time. Okay, less time possible. We'll be doing that after this lesson. See, because I telling biology lessons, some other faculty telling their lessons does not work for you guys within this 1.5 month of time which you have. Okay, so that is why you require much of practice in this. Okay, in this 1.5 month will be, that is actually not practice. We'll be planning out what to do, how to do everything. I'll be letting you know. From the next video, probably of mine will be that only. This is the last teaching video which I'll be teaching you. If at all, if you have any chapter recommendations or suggestions to be taught, just post it in the comment section below so that I'll be taking up those chapters. Otherwise, we'll be uploading the test videos only. Now, without any further ado, let's get into the video of excretory products and their elimination. First, we'll be discussing this under the subheading modes of excretion. So, what are the different modes of excretion that you guys know? A monotelism, urotelism, uricotelism. Okay, these are the three modes of reproduction. Oh, sorry, these are the three modes of excretion that are known till now. Ammonotelism, the animals which excrete ammonia. Okay, not animals. That phenomenon of excretion of ammonia is called as ammonotelism, and the phenomenon of excretion of urea is called as urotelism, and the phenomenon of excretion of uric acid is called as uricotelism. These are the three types of or three modes of excretion that we have. The first things first, ammonia requires much water, guys. More water is required by it. It requires more and more amount of water. Ammonia requires more and more amount of water. Urea, when compared to ammonia, it is less, but when compared to uric acid, it is more. Uric acid, it requires the least amount of water. Okay, least amount of water to get excreted. Sorry, I don't know what happened. A minute. This uric acid requires the least amount of water to get excreted. Okay, so based on this, different types of animals have adopted their means. Okay, different types of animals have adopted their means of excretion. Like ammonotelism, they require much amount of water to get excreted. So in which medium do you think the water is going to be in plenty? Which medium are you thinking that water is going to be plenty? Yes, aquatic medium. In aquatic medium, water is plenty, so they can excrete ammonia. They can afford the loss of water through which they can excrete ammonia. Next, ureotelism, in which urea is excreted. Which medium is the water in midway between these two? Not more, not less, in midway. That is your terrestrial. Okay, terrestrial. Fine. In which is the water less? It is the least among all. Yes, that is your aviation. Fine. Aviation. In that aviation, it is water is the least. Fine. Now, what are the examples of aquatic animals? Fishes and aquatic amphibians. Terrestrial, best example is humans. Aviation, aves, and also some insects also excrete this. See, have you ever seen a lizard's poop, which is hard, stony type? It is one type of excretion through excretion of uric acid, and reptiles also come under this uricotelism. Have you ever seen birds shit? That is a semi-solid form of excretion. Okay, that is a semi-solid form of excretion. So these are the different modes of reproduction that we can see. Now let us move on to the next topic, that is your human excretory system. What does this human excretory system consist at all? This human excretory system consists of the following. One, this red color one is your dorsal aorta. You'll be learning all these branches of aorta in your MBBS first year only. What is this? This is your vena cava. Which vena cava? Inferior vena cava. Yes, inferior vena cava. What is this? Kidney. What is this? Suprarenal gland or adrenal gland. Suprarenal gland or adrenal gland. Renal, we call kidneys, usually the terms which are associated with kidney we call as renal, and supra means above the kidney, that is your adrenal gland or suprarenal gland. What are these? Ureter. What is this? Urethra. Peak difference is there between ureter and urethra. Please do not confuse between them. This is urinary bladder. Okay. Still, this part where all the structures that enter the kidney and exit the kidney is called as hilum. Okay, that part is called as hilum. That part where all the structures enter the kidney and exit the kidney is called as hilum. Okay, fine. Yeah. Now this peculiar structure, which is inspecific, which is entering the kidney, these two vessels which are entering the kidneys, that structures, one is called as renal vein. I told all of you that anything associated with kidney is called as renal. The other thing is called as renal artery. ART means heart. Okay, so these are the structures that you guys have to remember. Fine. Okay, these are the things that are present in your human excretory system. Moving on, we'll be seeing the cross section of kidney. What does this kidney consist of at all? This kidney consists of two parts. Okay, for that matter, any organ or any gland or any organ consists of two parts. Okay, cortex and medulla. Cortex and medulla. This kidney consists of two parts, cortex and medulla. Cortex is the outer part. Anywhere cortex is the outer part or medulla is the inner part. Okay. In the adrenal gland also, cortex is the outer part, medulla is the inner part. Okay. And what are the important point here is, what are the structural and functional units of kidney? Functional and structural units of kidney. What are they? Nephrons. Yes, these nephrons are present in millions. Okay, literally millions. They are present millions in number. Okay, there is a specific count given in your NCRT. Let me just give you that count. So I'm not able to find that count. There is a specific count of which is given. Okay, I'm not able to find it out. If you find it out, please remember that specific compound. Usually, both the kidneys consist of millions of nephrons. Okay. Now, this medulla part, inner medulla part, which is present, it is divided, guys. Actually, this is divided. Okay, it is divided into many pyramids. Okay, and those pyramids are called as medullary pyramids. Let me show you in the diagram these structures. Okay. Can see black eye. Yeah, these structures which are present here, those are called as your medullary pyramids. These are your medullary pyramids. These are all the things which are present. These are your medullary pyramids, and inside these medullary pyramids you will be having these nephrons. This is a structure which is present in a medullary pyramid, and the space between two medullary pyramids is occupied by the cortex. Cortex innervates this space which is present between two medullary pyramids, and that space which is occupied by cortex is called as important columns of Bettini. Okay, columns of Bettini. We have two guys, Bellini and Bertini. Please do not confuse between those. Okay, these are the columns of Bettini. Yeah, columns of Bertini. And these places where these medullary pyramids are getting extended. Okay, let me just erase this black line so that you can see clearly. Follow me, cursor. This place where this renal renal pyramids also you can call them as, or in specific medullary pyramids, this space is called as calyx. Okay, that space is called as calyx. Singular is calyx and plural is calyces. Okay, calyces, through which the renal veins, okay, renal arteries, etc., pass through. Okay, and this place which is empty, this space, like not empty, but this space which is there, that is called as your renal pelvis. Renal pelvis. Okay, renal pelvis. Fine, are we fine here? Yeah, let me explain you how this blood comes and goes. Actually, what is the use of inferior vena cava? They take away blood from organs. So the blood first enters through the uh, renal artery. Okay, it enters through the renal artery, then it passes to the calyces, then it enters into medullary pyramids, and in this medullary pyramids it gets passes throughout the nephron, and urine is collected onto the collecting duct, and the remaining blood, okay, remaining purified blood which is there, it passes through the veins, and it goes into the renal vein, and this renal vein, it goes from this renal vein, it goes into the inferior vena cava, and above there's a dorsal artery. Dorsal. So this is the flow of blood. Fine, are you fine with this? And this renal this columns of Bettini are also called as renal columns. Any word associated with kidney, you put just renal. Okay, that will be doing the job. Moving further, we actually have the formation of urine and osmoregulation, but I want to explain you the structure of this nephron. Okay, this is the structure. Just do not see this. Just do not hesitate seeing that. I'll be explaining you. Just look at my thing. What is this? This part is actually glomerulus. Okay, glomerulus. And actually, let me try to draw that differently. Let me draw that. This is my way and NCRT's way of drawing an F1. Don't think that it will be like this. An F1 won't be like this, but it is my and NCRT's way of drawing an F1. Okay, this. Fine. This part is your, sorry, this part is your glomerulus. Okay, that part is your glomerulus, and this cup like thing which is enclosing the glomerulus is called as Bowman's capsule. Bowman's capsule. Okay, Bowman's capsule. And the artery which is entering is called as afferent arteriole. Sorry, AFF. Afferent. After effect, there will be effect. Okay, after effect, there will be effect. If one person gets affected, then you will be seeing the effect of that affection. Okay, remember like that. If one person gets affected, then you will be seeing the effect of that affection. This afferent arteriole, this is afferent arteriole. There are two arteries which are, sorry, actually arteries are the biggest structures, and then where they like when they decrease their size, when they decrease in the diagram, the diameter, they are called as arterioles, and further decrease leads them to capillaries, and from their venules, veins, and large veins, large. Okay, this is the organization which is present. Huh? So there are two arteries or arterioles which enter into the glomerulus. One is the afferent, which enters into the glomerulus is your afferent, and which exits the glomerulus is your efferent. Remember like this, or else exit E efferent, exit E efferent. Okay, that is your efferent arteriole, afferent and efferent arteriole. Fine. Now, what happens here actually? What actually happens here is, let me tell you. Usually, no one will be telling this. This is your blood capillary. Fine. This is your afferent arteriole. This is your efferent arteriole. And this is your Bowman's capsule. Okay. Like they'll be telling, but they will not be telling you in this rapid revision programs usually, which will be leading to people who are studying through this rapid revision programs only to a confusion. Okay, in order to clear that, I'm telling you this. Fine. See, this is your Bowman's capsule. This is your glomerulus. Here you will be having podocytes in the Bowman's capsule. The lining of the Bowman's capsule is your podocytes. Okay. In capillaries are not straight, right? They are not straight, like they are not non-porous, they're pores, they have pores. Okay, these capillaries have pores, tiny little pores. Now um, yeah, the blood which is present inside this capillary exit through this pores. It enters into the podocytes and it gets entering into the Bowman's capsule. Okay, Bowman's capsule. Here, most of the blood is filtered here actually. Okay, most of the blood is filtered here, like total some physical waste, like some like. mm, solid waste. Okay, solid waste, small types of solid waste which are present and which are essential usually. See, these pores might be bigger ones, no? Why they are not bigger? In order to prevent the exit of RBCs. Okay, in order to prevent the exit of RBCs, and also in order to prevent the exit of WBCs, they exit, but they prevent it, like they'll be protecting it somewhat, they stop. Okay. Now the urine, sorry, this blood enters here, and this rate through which the blood enters, through which the blood enters into the Bowman's capsule is called as glomerular filtration rate. Okay, this is a place where glomerular filtration occurs. Glomerular filtration occurs at this place. Okay, fine, fine. That is 125 ml. Okay, 125 ml. Sorry, yeah, that is 125 ml per minute in a healthy individual. This place is like the blood entering into the Bowman's capsule through the podocytes, through the slits into the Bowman's capsule from the glomerulus. Okay, from the glomerulus is your glomerular filtration rate. Am I fine, guys? Okay, no. After this Bowman's capsule, where does this blood enter? This enters into this PCT, proximal convoluted tubules. Okay, proximal convoluted tubules. If the spelling is wrong, just ignore it. Okay. Actually, this PCT and DCT, I asked my sir for like what are the extension forms of this. He scolded me. Uh, okay, he scolded me because it was almost like there were still 2 months left for completion of my 11th class. Then I asked me, he scolded me. But I don't want you people to get scoldings for me. But I will not scold you. But if you never remember this PCT and DCT, now what are the extended forms? Just write PCT and DCT, okay? Don't try to get this. Actually, these are proximal convoluted tubules and distal convoluted tubules. Just remember, convoluted tubules. CT is a common. P, proximal. Proximal in the sense, anywhere if you come across the word proximal, that is close to the body or close to the midline of the body. Distal. Distal means it is far away from the body. Midline. Okay. Remember that. Okay. This is your PCT. Now this bend, whole complete is called as hairpin loop or loop of Henle. Henle's loop of Henle, anything you can call. Okay. This complete thing is called as your loop of Henle. Fine. Let me just check the spelling. Loop of Henle. Loop of Henle is correct. This entire thing is called as loop of Henle. And this is your ascending limb of loop of Henle. This is your descending limb of loop of Henle. And this is your hairpin bend. Have you ever seen an hairpin? It is like this. Okay. So this also looked to that scientist as hairpin, so that is why he named it as hairpin bend. Okay, this complete is called as loop of Henle, and this is the ascending limb of loop of Henle. Sorry, this is sorry, I'm extremely sorry. This is the descending limb. Okay, small correction. This is the ascending. Sorry. This is the descending limb. This is the ascending limb of loop of Henle, and this part is your favorite and my favorite DCT, and this is your CT collecting and CD collecting duct, and this is your initial collecting duct ICD. Okay, these are the parts of a nephron. Fine, these are the parts of a nephron. Remember these. If you want, you can take a screenshot also. Fine, these are the parts of a nephron. Now let us move. Let me just clear the sink so that we can use it for some other thing. Let us move here. Urine formation and osmoregulation. Coming to the urine formation and osmoregulation. Okay. Now, how is this urine at all formed. I told you, I told you, I told you that. See, I told you that this is your glomerulus, this is your Bowman's capsule, these are your podocytes. Okay, these are your podocytes, and this is the entry of blood from glomerulus into the Bowman's capsule. Okay, this blood which is entering here is called as primary filtrate. This is 4 times concentrated. Okay, this is 4 times less concentrated than the final urine. Okay, this is 4 times less concentrated than the final urine. Why? Because it contains much amount of water. Okay, it contains much amounts of water. We require water in our body, so we have to remove that water, and this removal of water and electrolytes which are essential for our body is called as reabsorption. Why one absorption is already happening in the intestines, and this at this place it is again, if some other things are left, it is again reabsorbing. Okay, it is again absorbing, so it is reabsorption. This primary filtrate which is formed here is 4 times less concentrated. Means the final filtrate which is formed, final urine which is formed, is 4 times more concentrated than this primary filtrate. Both sentences mean the same. In NCERT they have written this, but they haven't told this. So they can ask you in exam this statement. They can give you this statement that primary filtrate is 4 times less concentrated than the final filtrate. So you will be opting it as wrong. Okay, and they can give you an assertion reason. They can ask you as which of the following is correct. Okay, like that. Now we have something important here in the human formation, that at which places what are the substances that are going to be reabsorbed. Let us now see that. Okay, let us now see that. Again, I am drawing the same diagram which I and NCERT allows actually to draw. Fine. But this time it is not much clear than the previous one. Okay, what is this Bowman's capsule? What is this glomerulus? What is this afferent arteriole? What is this efferent arteriole? What is this PCT? What is this Henley's loop? What is this hairpin bend? This is descending limb, ascending limb, DCT, initial collecting tract, and collecting tract. In the PCT, what are the substances that are being reabsorbed? Okay, these are the substances which are being reabsorbed. Usually, water is present everywhere except in this descending limb of in this ascending limb of loop of Henle. Water is reabsorbed everywhere except there. K plus nutrients. Most of the absorption occurs here only in the PCT proximal thing only. 90% of the absorption occurs here only. Okay. There are some substances which are also secreted into the urine, that is H plus and ammonia, which we don't require. Okay, which we won't require actually. So this, as this primary filtrate pass through these things, this thing happens. Okay, as this primary filtrate passes, the HCO3 minus, okay, NaCl, nutrients, water, K plus are reabsorbed, and H plus and ammonia are added to this primary filtrate. Now, in this descending limb, how should you remember the concentration? This is reticulous. Absolutely ridiculous. How can you remember the concentration actually? Here concentration is important. Where concentration is decreased, where concentration increases. Okay. A descending limb, remember that it is a waterfall. Waterfall. From high mountain top, water is falling. Same here. From the PCT, water is falling into the descending limb. Then the water gets displaced here. Same way, water gets displaced. So water gets reabsorbed here. Waterfall. Water decreases means concentration increases. Simple. Okay, anyone means the same. Here in descending limb, this happens, except what nothing happens here. In hairpin pen, no reabsorption takes place, but in ascending limb, water is not reabsorbed, but electrolytes are reabsorbed. If electrolytes are reabsorbed, what it means? Concentration decreases. If concentration decreases, then the dilution increases. Okay, both means the same. Here they can play tricks with you, giving you different of sentences, but everything means the same. In NCRT, there is only one sentence written, but you have to think of the other possibilities how they can give the paper. Okay, that is the NaCl being reabsorbed. In this ascending limb, you have two parts. One it is the thick ascending limb. Okay, thick ascending limb. Another one is the thin ascending limb. Thin and thick. In both the places, NaCl is reabsorbed, and urea is secreted from the collecting duct. Okay, urea is secreted. Actually, this urea is reabsorbed into the interstitial fluid, and this urea, which is reabsorbed, it is again secreted into the thin ascending limb. Now, coming into DCT, almost all the substances which are similar to the PCT are only reabsorbed, but some substances are not reabsorbed. Which are those? So let me tell you. NaCl is reabsorbed. Okay, NaCl is reabsorbed here also. Water is reabsorbed here also, and HCO3 minus is also reabsorbed. But nutrients K plus are not reabsorbed, and K plus is secreted here. Okay, secreted here, and H plus is also secreted. Right? Primary. Fine, guys. Fine. Fine. In the conducting duct, water is again reabsorbed, and urea is also reabsorbed, and from this again it is secreted into the thin ascending limb. Are you fine with this? If you are fine with this, we are I am very much lucky to have you guys, because that is the major part which you have to understand. Okay? Major part which you have to understand. And after that major part, you have to understand about this major part which I am telling you now. Osmo regulation. Osmo regulation. Actually, in this nephron, where this hairpin bend or Henle's loop is present, surrounding that we have vasa recta. Okay, we have vasa recta, and from this vasa recta, okay, from this vasa recta, again the blood. Actually, this is the blood. Actually, okay, this is the blood, which is which is rounding the Henle's loop or hairpin bend, and this blood again enters into venules and veins and again inferior vena cava, and it again goes into the right atrium of the heart. And we have osmoregulation taking place between this vasa recta and the hairpin bed, and also the interstitium. Why this has to occur? Okay, why this has to occur? First of all, tell me in the comment section below. Okay, tell me in the comment section below why this has to occur. Okay, fine. Now, what happens here is, in these areas of this loop of Henle, water is reabsorbed, right? Am I right? Water is reabsorbed, and NaCl is again reabsorbed. Okay, NaCl is reabsorbed, water is reabsorbed. Okay, we require NaCl. Okay, for our body. Sorry, no, we require water for our body. This water has to reach the body parts. So that is why it mixes with the blood. In order to mix with the blood, it has to go inside the vasa recta. Okay, it has to go inside the vasa recta. So water which is reabsorbed from the nephron, it enters into the vasa recta. And NaCl, which is vasa recta, is also having two limbs actually, and they are different. See, this becomes your descending limb, and this becomes your ascending limb. They are opposite to that of the loop of Henle. Okay, they are opposite to that of the loop of Henle. This water which is here, it actually it goes into the interstitium. it goes into the interstitium, and NaCl which is there in the blood also, it goes into the interstitium. This NaCl, it enters into the urine, and this water which is here, it enters into the vasa recta. Okay, these are the osmolarity. This is the osmolarity: 300, 700, 1000, 1200, 1500, 400. Okay, this is 1200 at the interstitial fluid. uh, I'm hoping this question to come in on this NEET. Okay, interstitial fluid. Okay, just go through this osmoregulation, it will be very easy. Just go through this osmoregulation. We completed this thing. No, regulation of kidney function. Let me wait. Let me just check video is recording or no. Yeah, it is recording. This will be your last but one topic. After this, we will be having the role of other organs and disorders. Okay, I'll not discuss about the role of other organs. You just read on your own. I'm also expecting a question from that also. Regulation of kidney functions. We have got something called as juxtaglomerular apparatus. What is this juxtaglomerular apparatus? Actually, uh, what to say? Actually, the place where afferent arteriole and DCT meets. At this place in the DCT, we have at this place where the afferent arteriole of glomerulus and this DCT meet is called as juxtaglomerular apparatus. Okay, juxta means between, glomerular means glomerulus. That is called as juxtaglomerular apparatus. And in this DCT, we have some peculiar cells called as macula densa cells. They are only present at this place. Okay, at this place we have macula densa cells. What does this macula densa cells do? These macula densa cells are also called as JG cells. What do these JG cells do? These JG cells secrete renin, not RENNIN is different, RENIN is different. Okay, RENNIN and RENIN. RENNIN is a milk casein. Okay, that is an enzyme, and RENIN is your what? Which is your also an enzyme which is secreted by the JG cells. And erythropoietin. Okay, erythropoietin. What it does? Erythropoietin is secreted when low oxygen levels are there, and which increases the production of RBCs. This renin, which is present here, this renin, which is present here, this renin, which is present here, it activates angiotensinogen into angiotensin 1. This is what you called as, I'll be telling you. Okay, angiotensin 1. And this angiotensin 1 with ACE enzyme, angiotensin converting enzyme, it gets converted into angiotensin 2. This angiotensin 2 being a powerful vasoconstrictor itself, it constricts the blood vessels. When it constricts the blood vessels, what happens? BP increases. If BP increases, glomerular filtration rate increases. Okay. If BP increases, glomerular filtration rate also increases. This occurs when glomerular filtration rate is low. This thing happens. Okay. This is called as renin-angiotensin mechanism. Okay. This is called as renin-angiotensin mechanism. Angiotensinogen converting into angiotensin 1, from that angiotensin 2, angiotensin II being a powerful vasoconstrictor, it constricts the blood vessels. Also, it acts. Sorry, wait. Is the thing visible? Let me just check. Yeah, it is perfectly all right. Yeah. This be not even being the powerful vasoconstrictor, it also activates the adrenal cortex in order to release adrenaline, which is also a powerful vasoconstrictor. This also constricts, which increases the BP, and this BP increases causes what? Increase in the glomerular filtration rate. Fine. Now we have another hormone. Okay. We have another hormone which is called as ADH. What is this? Anti diuretic hormone. Diuretic hormone. Diuretic. Uretic means release of water. Okay, sending of uresis means more and more amount of water going through the urine. Diuresis means in order to prevent this. Okay, diuresis means this one. Anti-diuresis means prevent this. This acts upon the DCT part. Okay, DCT part. And whenever, okay, this isn't powerful. This is also called as vasopressin. Why it is called as vasopressin? It is a vasoconstrictor. It presses the blood vessels, vasoconstrictor. Again, if blood vessels are pressed, BP raises. If BP raises, what happens? Glomerular filtration rate increases. Now, there is only one hormone which decreases the BP, that is your ANF, anti-neuritic factor, or ANP, anti-neuritic peptide. This is released from the right atrium of the heart. 1 minute, guys. So, sorry guys for that disturbance which was caused. Uh, so, this ANP or ANF, which is released by the right atrium, is a vasodilator. Whenever the BP increases, this is only the thing which is given in your textbook. Whenever the BP increases, it is released from the right atrium and it reduces the BP. On reducing the BP, GFR automatically gets reduced. Okay, that is the regulation, guys. Moving on to the role of other organs, I ask you to study this. This is here. This your job to be done. Okay, if you have any doubts regarding this, comment down. I'll be replying to that. Now, coming into the disorders. Disorders. What are these disorders of excretory system? We have different types of disorders which we are given here. One of this which you have to learn is about hemodialysis. Hemodialysis. In this, most important thing is about the dialyzing fluid. This dialyzing fluid is in similar composition to the uh, blood, but but it has not got, oh, the nitrogenous wastes are absent in this. Okay, so through whenever the blood is drawn actually from the body, when blood is drawn from the body, it is sent into the dilator, uh, dialyzer actually, dialyzer, the machine, by addition of heparin, which is a natural anticoagulant, in order to prevent coagulation of the blood. In the dialyzer, it is filled with dialyzing fluid, and when this artery enters into this, through diffusion, these nitrogenous waste materials get diffused into the dialyzer, and the fresh blood enters into the human body again. Okay, this remaining waste which is there, it gets exited. Okay, it gets excreted. This is also called as artificial kidney. Okay, that is the thing that you have to remember. Now, coming into renal failure. Yeah. Renal failure. What is this renal failure? If the kidney stops to act or function, when your kidney starts to function or any malfunctioning is there, it gets stopped. So at that time, renal failure occurs. When renal failure occurs, transplant is only one option which you have in your hands. You have to transplant being a donor. Okay. From a donor, you have to transplant into the patient. Fine. That is your renal failure. Next one, renal calculi. Renal calculi. These are something which are also in general terms they are called as kidney stones. They are called as, sorry, they are called as kidney stones. Okay, in general they are called as kidney stones. They are the insoluble crystallized forms of sodium urate or urate crystals in general. Okay, urate crystals in general. Fine. Next one, glomerular nephritis. Itis, whenever you hear the term itis, it means infection. Glomerular nephritis. Where does this occur? In the glomeruli of the kidney. Okay, infection of the glomeruli of kidney is called as glomerular nephritis. So that is it for this video, guys. Thanks for watching. This is Vamsi. This is Sundar, actually, my full name. So this is Vamsi signing off from NEET Atomics, and hope you all have a great day further. Thanks for watching. Bye bye. If you like the video, please hit that like button and also subscribe to our channel NEET Atomics.